Welcome to the Sensei Scott Coding Dojo. This is the instructional video for issue 2, where we go through SQLite. So what I have here on my screen is my GitHub repo for the Coding Dojo, and you can see there is a issue 2 folder. In that issue 2, there's the database files showing the 5 database files that we'll be using for this video. So what you can do is you can go to the main page for the repo, and go to code and download this as a zip, or you can download it through GitHub. I have it downloaded here to the right, so once you have those 5 files, we can go ahead and get started. So as you see, we already have the code out here as well as the database. But for now, I'm going to go ahead and delete these. And what I'm going to do is I'm going to open this in Visual Studio Code. All right, so I can open this here, and we can see our 5 files. Now the first thing I'm going to do here is I'm going to open up or create a new file for SQL demo, and I'll call that a Python file. And from here, what I actually want to do is open it in a Jupyter notebook. So I'm going to press Control-Shift-P, and I'm going to search Jupyter, and I'm going to create a blank notebook. So here we can just use Jupyter to run our code. It allows us to isolate some parts of our code and only run certain sections for testing and debugging, which is very helpful. So first thing we're going to do is import our libraries. So we're going to import SQLite 3, and I like to call it SQL, and we're going to also import pandas as PD. So if you don't have pandas, you may have to pip install pandas, but SQLite 3 comes built into Python 3. So that is our imports. So we can run this, choose our debugger. I'll choose this top one, and that should just import these 2 modules. I'm going to go ahead and add another coding block, and here what we're going to do is create a connection to our database. So I'll call this con, and what it's going to be is sql.connect. And then we're going to give it our database and name. So we can go ahead and call this dojo.db. And also, so what this will do is it'll create a connection to a database. If this database file doesn't exist in this issue 2 directory, it will create the file. If you wanted to create this in memory as opposed to creating a file, what you can do is SQL connect, and then instead of the file name, you would put a colon, memory, colon, end quote. And that will create the database in memory, making it so there is no file holding the data. It's all done in memory. So I'll go ahead and create a connection to the database, and what we'll see is we now have our dojo.db file that popped up here on both windows. The next thing I'm going to do is import our files using pandas. So first I'm going to create a list of files. Our files are going to be equal to the names of those 5 files. So we have location, region, product, location, region, and lastly, sales. Now what we're going to do is for file in, well, I'll just call it F in files, we're going to do a data frame. First, we're going to create a data frame. If you're not familiar with data frames, it's part of the pandas library. It basically looks like an Excel spreadsheet inside of Python. There'll be future issues where we cover pandas in more detail. But for now, we're just using 2 lines for pandas, and that's reading our CSV. So we have _read CSV, and we would just put the file name. So since we're in the issue 2's folder, we need to first go into the db_files, and we need our CSV, or our file really, .csv. So what we have here is called an F string, and basically this allows us to substitute variables by using these braces. So F will be replaced with the file names of each of our 5 files, and then we have our extension for .csv. Once we've loaded it into a data frame, we would then convert it to SQL. So there's df.sql, and here we need to place the CSV name or the file name. This will be the name of the table. So inside of the database, we'll have the table names that will be the same as the CSV names. We then need the name of our connection, or our connection rather, and then if it exists, we will replace. This can also be used to append. So if you're importing the same file twice, you may want it to append in the database. If we do it twice, we want it to replace. And then lastly, we want to turn off our index. We don't really need that for this example. So we can go ahead and run this code, and nothing kind of shows on the surface, but let's see if we can do a print df. So this will then show the sales table. So you can kind of see we have the location ID. So this is the location, this is the product. So what product they purchased and how many pounds they purchased of the product. So you can kind of see it looks kind of like an Excel spreadsheet, but all done within Python. So the next thing I'm going to do is create what's called a cursor. So typically we call this C equals con.cursor. The cursor is basically a way to drive the database. So if you want to execute queries, you would use the cursor to do so. So we need this to be able to execute our queries. So this is the basic setup that we need. Our next step here is to actually start running a query. So let's add another code block. I can clear this output so there's a little less on the screen here. It lets me click. And we're going to go ahead, as I said, execute our first query. So we have c.execute. So with our cursor, we're executing the following query. Let's just do a simple select star from location underscore region. So what this will do is it'll execute a query selecting all of the column headers. That's what this asterisk means. It means every header from the location region table. So in theory, this will just return this CSV file. So what we can do is, in order to print this out, we would print and then c.fetchAll. FetchAll just returns the data. If we want to show it to the console, we need to print it. So if we go ahead and execute this, it looks like there's an issue there. I might have forgotten to execute that line. So there we go. So now we have a list of tuples with each location and each region kind of laid out here. So all in all, this isn't super helpful since we don't have names, so we don't really know exactly what everything is. So in the next query, we're going to go ahead and add names to this so we can see the region name and the location names. So we'll add a new code block, and we'll do another c.execute. And this time, this query is going to be a little longer, so I like to do it in 3 quotes, so I can do it on multiple lines to give myself some space so I can, write the query properly. So first thing we're going to do is select, and what we want to show here is the location names and the region names. So I'm going to select location underscore name, region underscore name. And now those are the 2 columns we're selecting. Now we need to say what tables we're selecting them from. So we want to select them from, it's really a combination of 3 tables. We are first going to join location to region, and then we're going to join that to the location and the region. So if we do location, region, so let's just look at these 2 queries first, and we'll view the output. So we're selecting the names from each of these tables. That should say join. But first we need to do is use a where clause, basically stating which headers are the same. Well, actually, we don't need it for this because there is no similarities between location and region. If we were to look, we have location ID and location name, and region is region ID and region name. So there is no common headers here, so we actually don't need this where clause. But in the next part of this query, we will. So let's go ahead and print c.fetch. We'll just do a fetch many for our case, and we'll just do the top 10, or the first 10 rather. So instead of fetching everything, this just fetches the specified number of items. So if we were to execute that, what we'll see is we'll actually get a pairing of every state or every location with every region. So as you can see, this isn't very helpful because Alabama can't be the far west and the Great Lakes and Mid-South. So this is where we actually need an additional table, the location region table, that ties the two locations and regions together. So what we're going to do is we're going to join location underscore region. And then here's where we're going to need the where clause. So for the where clause, we basically need to specify what column headers are the same between the two tables. So what we would really have is location dot location ID is equal to location region dot location ID. So that's one of them. We also have it for the region, so we would need and I'm going to go ahead and just copy this, make it a little quicker. So this would be region So we have the location ID is the same in the location table and the location region table, and the region ID is the same in the region table and the location region table. So if we go ahead and run this now what we'll see is Alabama Southwest, Arizona Mountain West, Arkansas South Central. So now we can kind of see that this makes more sense. We have the different states or locations lined up with their appropriate regions. In the next query, we're going to go ahead and look at some sales data. So let's add another code block. Here we're going to do c.execute again. And again, I like those triple quotes there. And what we're going to do is, I'm going to clean that up a little bit. So select, for this one, let's go ahead and grab the location name with the products they've purchased, and then the pounds of purchasing and the price of the purchase. So if we kind of look through our data, we have, so we have our locations, and we have our products, which show our IDs, our names, and our price per pound. And then if we go to sales, we have the location, the product ID, and the number of pounds they've purchased. So what we can do is we want to select the location name. We want to select the product name. We want to select the price per pound. And lastly, we want to grab the pounds. So we're selecting these 4 columns from, we need to join the location table with the product table with the sales table. And again, we need to specify where things are similar. So in the sales dot location ID equals location dot location ID, and the sales dot product ID is equal to the product dot product ID. So it's very similar to the last query, just 2 different tables. Let's see here, see if we missed anything. All right, so we can go ahead and let's do a print c.fetch all, and we'll go ahead and run this guy. So it looks like we have an issue here. Let's see, so no such column, price per pounds. So let's go to the sales, or the product as price per pound. So I think I have an extra S there. So let's try that again. All right, so we have, now we have our location, the product, and the amounts for each. So we have the price per pound and then the pounds. Great. So the next thing we can do here is, instead of showing the price per pounds and the pounds, just show the overall price. And what we can also do is sort that to show the highest purchasing product down to the lowest. So let's go ahead and add another code block here. Let me clear this output and add another block. So I'm going to go ahead and copy this because a lot of it will be similar. Now here, instead of showing price per pound in pounds, we can actually multiply these two. And we'll have to put them in quotes, and then we can give it a name, and we'll go ahead and call it price. And now towards the end, after the where clause, we can order by price, and we want it to be descending. And this will show the prices in descending order. Now again, instead of fetching all, let's do another fetch many, and we'll do the top 20. So I can go ahead and run this here, and what we'll see is we have Nebraska for Rami at 5,925, and then Georgia limes, Michigan copper expeller, and so on. So we can run this again, and we'll see we'll get the same results. So that's good. But one thing we probably should do here is print this in a little nicer fashion, just so we can make it a little more readable. So let's go ahead and do that. So first, we want to print the, we have a name, we have a product, and we have a price. And actually, instead of name, call this location. So we print that. We also need to grab the data from the query. So what we can do is, let's just call it data equals c.fetch many. Instead of 20, let's do 50. So now that we have the 50 top items, instead of printing it, we're just storing it in a variable. And the next thing we can do is iterate. So for line in data print, so we're going to do another f string here. We're going to go ahead and print line 0, line the braces, line 1, and since the last one's a price, let's go ahead and throw a $sign, line 2, and we also want to format it with 2 decimals. So that's the :.2f means. So it looks like I need a closing quote, and that should be good. So we can go ahead and run this now, and looks like our data is a little different. So let's take a look here. See if we run it again. So we're getting different results. Let's go ahead and run this, run that. Maybe if we comment this out. So what we're seeing here is every time we call this, we're fetching the top 50, and then those 50s basically get flushed, and then we're grabbing the next 50. So when we run this in tandem, we'll see we'll get 50, then the next 50, then so on. So in order to actually print the top 50, what we'll need to do is print that and only fetch once, because if we fetch many and then fetch many again, we're not going to get the top values. So as you can see here, we now have the Rami here at the top, followed by the Georgia limes. So everything looks good. All right, so for our last query, what we're going to do is get some user input. And then we're going to use a query that uses that user input as a sort of validation inside of the query. So first thing we're going to do is we're going to execute a query that's going to select all of the regions in our database. So we can select region name from region, and then what we're going to do is convert this from a list of tuples to just a single list. So if we go regions equals reg 0 for reg in c.fetchAll. So that'll give us a list of regions, and now what we need to do is prompt the user for input. So we'll do a while true, and we'll go ahead and print the available regions. And what I'm going to do is I'm going to separate them by a comma and a space. So that'll list all of our regions. And then I'm going to ask the user for input. So our region is going to be what region would you like to see sales data for. And that should actually be an input. So let's go ahead and it looks like we got an extra E there. So we're going to ask the user what region they would want to see the sales data for. Now, if that region, so if the user's response is in regions, then we want to break else we want to print invalid region, and then the user would, it would print out. So if they didn't give a valid region, it would print out invalid region, and we'll go ahead and print the regions again and ask the user for a region. So at this point, once we exit this while loop, once we execute this break statement, we'll then have a valid region. So what we can do is go ahead and execute our query. So we have, again, c.execute. And in this query, what we're going to do is get the region name, the product name, and the price, similar to our last query. So I'm going to go ahead and scroll up here to this query, just kind of copy it, so we can limit the amount of typing we have to do. So we're going to get our, instead of location name, we want region name. We have our product name and then our price. So we want to join region, join product, join sales. So what you'll see is sales doesn't have the region ID. So we actually need to join this region with location in order to tie the region to the sales. So we have our sales will equal our location ID. Our location ID will equal, our sales location ID will equal our location ID. Our sales product ID will equal our product ID. And we'll also have where our, looks like we actually need another table here joining region and location. So let's go ahead and join that. So then we'll have our region location dot region ID. So a lot of statements here, but hopefully it's making sense why we need these. All right, so now we have our region. So now we can basically tie together our region to our region location to our product to our sales. So we should have sales location equals location. Okay, so this should tie everything together. The last thing we need here is and region name equals question mark. So basically this is saying, based on the user's input, the region name in the query should match that constraint. So what we can do here at the very end is after the parentheses, we put in our parameters. So this will be region followed by a comma. So this is a little weird here. Whenever you have one input, you would need a tuple with an item and then a comma. If you have more than one input, you can just put region, without a comma at the end. But when you only have one input, you need to end it with a comma. So this should be good. So just kind of thinking through again our query, we have our region name, product name, and then our price. And from the region, we want to get the region name. And then in order to join it to our projects, we need to tie our region with the location. So actually thinking about it, we don't really need this region location because the only thing this gives us is our location name. Whereas the region location table will give us our region and location IDs, and that's really all we care about is those ID So we just took out the location table, so we don't need this and statement. And we also don't need this and statement because, again, we don't have, or this conditional statement because we don't have location. So if we back that out, we now have sales product ID equals product ID, region location region ID equals region ID. I'm trying to see if I missed anything here. So we still have our location ID that we need. So we would need our region location ID equals our product dot location. Actually, it'll be our sales location ID. So this is where everything kind of ties. So in sales, we have a location ID. In location region, we have our location ID. So that's how those will tie together. Looks like I'm missing some equal signs there. And then again, ordering by descending price. So let's go ahead and store this. So we'll say sales data equals c dot fetch all. All right. So let's go ahead and run this here. So you can see it's prompting us for our region, and then we have our input at the top. So let's do Great Lakes. Looks like we have an error here, no such table or region location, because it's location region. So let's do location region. All right, so let's go ahead and run that again. We'll do far west this time. Another error, no such sales ID. Where do I have that? Sales ID. Yes, this should say sales.location ID. And let's give it a go one more time. We'll do Midwest. All right, so it went through, so that looks good. So we can go ahead and add another code block. Let's print that out. Sales data, and we'll run that. And you can see we now have our sales data here. So we have Midwest Rami, and then actually, if you remember above, we showed the Rami there with our value, and it looks like it's descending, so that looks pretty good. So what we can do, again, we'll go ahead and print this a little prettier just to make it easier to read. So let me grab this data again, and I'll paste that over here. So we already have the fetch. So this time we have region. Well, we don't really need to print that. So what we can do is instead we can use an F string, and we can say sales data for region. And then let's go ahead and print a separator. So let me just close that just for the sake of ease to read. What's great in Python is you can multiply strings to just have them repeat. So I'll do that times 30. And next we'll just print product and price. So then for line in sales data, we can go ahead. So we have the region as the first one, so this would be 1, and then we can go ahead and just print the value with the same formatting as above. So we go ahead and do that. So we have sales data for the Midwest, we have our product, and our prices listed in descending order. Great. So the last thing we're going to do here is just close our connection of con.close. Now, I will say one of the things I mentioned in the issue, if you did make changes to the database where instead of just querying data, you were inputting or deleting data, you would need to do a con.commit before you were to close the connection for the data to be saved. Just like that. So this was some of the basics of SQLite and using it in Python. There's definitely a lot more to SQL, just, like using different statements and different types of joins. So if this is interesting, definitely take a look into SQLite and some of the SQL commands that you can use. But yeah, hope you enjoyed this video, and I look forward to seeing you in the next video next week.